Similar triangles have the same inside angles. But not the same side lengths. We say their side lengths are proportional but not the same. Clearly label the sides of the proportional triangles to determine which side is missing. Set up a proportional equation and solve for the unknown. Here we have two triangles that are similar. If we want to find the missing side, we need to identify which legs are going to be the comparison legs, so let's color code them. I know that 9 meters is proportional to the unknown leg on the small triangle. I also know that if the angles are the same, that 7 meters for the other leg is proportional to 4 meters on the small triangle. If that's the case, I can now set up a fraction for the large triangle. It would be 9/7. And if I want to set up a proportional equation, I can say that it is equivalent or proportional to x/4. Notice that the numerator on the first fraction is 9 and is similar to x, which is the proportional side of the similar triangle, and it is x, and it is also in the numerator. I couldn't write it as 4/x because then it would not represent the same side for the triangles. Now I can simply clear my fractions. I know 7 and 4 are the denominators I need to clear, so 9 times 4 equals x times 7, or 7x. I could write it either way. And now, since I need to solve for x, the unknown, I'm going to divide both sides of my equation by 7. This will give me x is equal to 9 times 4, which is 36, divided by 7. This does not reduce, so you could write it as a decimal, but the unknown side's precise answer, exact answer, is 36/7. In example 2, we again have two similar triangles. However, this time they're not in the same orientation, so it might be a little harder to identify which sides of the triangles are proportional. My recommendation is to identify the longest leg of the triangle first. I know that 8 and 20 inches are now the proportional legs, and so I can identify the angles that are the same right here. So this will help me identify which parts of the triangle I know and which parts I don't know. Since I don't know what x is the shortest leg of the triangle. So I'm actually going to use that knowledge to set up my fractions and my equation. Now I can write this as x/20 equals 2/8. Notice that the shortest leg of the triangle is in the numerator. So I have to keep that same pattern in the second fraction. The longest leg is in the denominator for both, and so now I can solve for x. 8x is equal to 2 times 20. This is just clearing my fractions, and then I can divide both sides by 8 to solve for x. This gives me x is equal to 40 divided by 8, so x equals 5. So the side that I didn't know is 5 inches.